start out today, you need to have this worksheet, this packet that we got about 2 weeks ago, has measurements on the front, adding and subtracting measurements. Need to find that one and dig it out. What? Need to find it. What's that? Sucks to be you. Let me see if I have more copies of it. Okay, now that everybody has a packet, we've got 2 hours to crank through as much of this packet as we can. So let's take a peek here. We've already done all the stuff similar to 31 through 38. The first page we've already done, did that a couple weeks ago. So we're going to the second page here. 31 through 38 should not be a challenge really to any of us. Other than the fact that we are doing all of our measurements, guys, stay with me. All of our measurements are being converted into feet, inches, and sixteenths now for this packet. So I don't want anything left as decimal feet anymore. It's got to be feet, inches, and sixteenths. So what we're going to start out with is a problem like 39. This is not problem 39, just so you don't get confused, but it's a problem similar to 39. Where instead of just having a straight rectangle, we have this extra dimension right here. Anybody know what that dimension is called on a truss? It's referred to as a heel height. And that is, the heel is measured where the truss sits on the wall. The height of the truss at the outside edge of the wall. So right up from here up to the top of the truss, going straight up the outer edge of the wall. That is your heel height. So we're adding a heel height to our trusses now. And let's say that this heel height here is 9 inches. Now there are 3 or 4 different types of heel that you want to look at. There's a common heel, or it's often called a type A. That is if you take a 2x4 and cut it at the angle required to make your slope. So that this now is what we call a plum cut. It is straight down above the outside edge of the wall. And you add to that a 1/4 inch. That 1/4 inch comes from the fact that your bottom chord is going to be on there like that. And when you cut that bottom chord, you can't just come right in at the corner of the board. So they always go up a 1/4 inch from the edge to start that cut. Otherwise the saw hits the corner and it can deflect off to the side a little bit. So you're going at that 1/4 inch is what's called the butt cut. That butt gets added to the angle cut of the 2x4 to give you your full heel. So once we get into trig here in a couple of weeks, we'll be able to calculate the actual dimension of this. Actually, we could calculate its actual dimension right now. It's not that tough. If this is a 412 slope, we can find all the angles on it, but we're not going to get into that right now. You could use a speed square to cut it, but you still have the length is what we're looking at right now, what the length of that cut is. And what it would be is you could take that 412 triangle and you could actually put it in right here. And you can make adjustments off of it, but we're not going to worry about that right now. So anyway, we've got a 9-inch heel. Let's give this thing a 30-foot span. And an 812 slope. Let's find the height and the length of the common rafter. We're going to find H, and then we're going to find J, which is the common rafter length. How do I find H? Well, I'm going to use my slope of 812, but the problem is that 812 is a triangle, and there isn't a true triangle here, so I have to make it. So I cut this across here to make a true triangle. This is still my run of how much? 15 feet. all I've done is remove that 9 inches. So what I'm going to find here is this dimension. I'll call that x for now. So 8 over 12 is going to equal x over 15. If I cross multiply and divide, 8 times 15 divided by 12 is 10. That means this is 10 feet here, from here to here. What's my height then? My height is 10 foot 9 inches. So now when I go to find J, what did I do wrong there? What's that? Why is it just 10? It's 10. I thought the height was 10 foot 9. Why do I take out the 9 inches? Yeah, the 9 inches is down here. That doesn't contribute to the slope. We're just using this triangle here still. This is my J. So it should be just 15 squared plus 10 squared. $18.028. Now, I've showed you this in the calculator before. Once you get this in the calculator, you don't clear it out, don't write it down. We're going to take the 18 feet off of it, and then what? Subtract 18 to get rid of the 18 feet. Now, times what? We're in feet, so we're going to take it to inches. Times 12. Gives us 0.3, so that's 0 inches. Then times 16 to make it 16ths. So it'll be 5.3. So that is 18 feet and 5/16 of an inch is what J is there. Does that make sense? Now I'm going to add a different feature. This time I took out the heel height. There's no heel height in this. But I added overhang. So let's say this has a 2-foot overhang, 38-foot span on a 7/12 slope. Let's find my height and J, the length of my top chord there. How do I find H? This is 19 for my run, so yes, 7 over 12 equals H over 19, and we will cross multiply and divide. 7 times 19 divided by 12, 11.0833. Which means that this is 11 foot 1 inch. If you don't believe me, subtract the 11 times the 12. There it is. So now we have to do J. So what's going to be wrong with this? What's wrong with it? Yeah, it's not 19 anymore. It's actually 21 feet. Because I have to add the 2-foot overhang. So it's 21 foot out there. Is 11.1 my height still? No, it's not. We've got to find a new height. So we're basing off this 21-foot triangle now, 21-foot run. It's still a 7/12 slope. That's the only thing that does stay the same. So we got to do 7 over 12 equals, we'll call this y here, over 21. 7 times 21 divided by 12 gives us 12.25 here. Then this will be the square root of 12.25 squared plus 21 squared, giving us 24.312 feet. So that is 24 feet. Subtract the 24, then what? Times 12. 3.7, so 3 inches. Subtract the 3 and times 16 to make 16ths. 11.8, so 12 sixteenths or 3/4 of an inch. So 24 foot, 3 3/4 inches is the length of that top cord. What do you think? Good stuff? Okay. Well then let's add in both. So let's go 18-inch overhang, 28-foot span. We're going to go 612 slope and a 14-inch heel height. I want to find H and J. Tell me where to start. Okay, I'm going to go across there. Now what? What goes down here? That's 14 feet. So this I'm going to call X for now. So 6/12 equals X/14. Cross multiply and divide, X is 7. So 14 inches onto 7, that's going to be 8'2". So H is 8'2". Everybody see where the 8'2" came from? Does everybody see where the 7 came from? You look confused, Mike. You got her? All right. Now that we have that height, that is the full height because we already added the 14 inches to it. Unfortunately, because there's heels and overhangs, we can't use that number again. So what we have to do now is this. Make that triangle. That triangle still has a 612 slope, but on bottom here it's 14 feet plus 18 inches. So 14 plus 18/12 is going to be 15.5 feet. Or 15.5 if we leave it as a fraction. So I'm going to call this here y this time. So we've got 6/12 equals y over 15.5, which ends up giving us 7.75 feet. Now all we want that for is so that we can find this, which will be the square root of, get out there, square root of 7.75 squared plus 15.5 squared. We get 17.32330. Now again, that's not so important because I'm going to use the calculator to get that feet, inches, and sixteenths. So I've got 17 feet. Subtract the 17 and then times 12. So 3.9, so that's 3 inches. Then what? Minus 3 times 16. I get 15.27. 15 is what it rounds off to be, 15 sixteenths. What if that were like 15.5? I would round it up to 16 sixteenths. It would be another whole inch. I'd just add 1 more inch and there wouldn't be a fraction. So I get 17 feet, 3 and 15 sixteenths inches is the length of that top cord. How do you guys feel? You think you guys can do this? No? Well, I'm going to give you guys about 10 or 15 minutes to work here. I want you to try to get up through number 60. So problems 31 Do 60. I want you to try to get done. Or jump around and do as many of them as you can so that you're sure you know how. I'll give you about 15 minutes. So let's just look at a couple here. When did you get number 45 done?
We're still at 41.
41, okay. Well, let's take a look at number 40, since you're at 41, right? Did you get number 40 wrong? Did you get number 40 done?
Yeah.
You had a 40-foot span, 13-inch heel, 10-12 slope. J turned out to be 26 feet and 7/16 of an inch. H ended up being 17 feet 9 inches. How many of you had that? How many of you have no clue where that comes from?
I got 3/8, 26 and 3/8.
That's just round off errors. That's acceptable.
Okay.
That's within a 16th.
If we're off a 16th or 2, that's not that bad.
1/16 is not bad. 2/16 would be wrong. Okay. Well, we're going to take a look then at the next type of problem, which starts on number 61, is an attic truss. In an attic truss, a couple of things happen. First, they're making a space inside the truss like this, where they don't have any webbing or any reinforcing. It's just an open space. So you can have a room up in the roof of your house, in the attic of your house. To do this, a couple of things usually happen. One is this bottom cord down here is extremely thick. A minimum of a 2x8, often a 2x10. They try to avoid splicing in the middle of the room just because 2x8s and 2x10s can have up to a 1/4 inch difference in width, so they can be uneven. So now you try to put your floor in there and you got unevenness. It's a real pain. The other thing that happens is they try to make your slope steeper so that you get a bigger room. The steeper that slope is, the sooner you get up to a reasonable wall height so you can put in the wall of that room. Now we are assuming what we call wire frame trusses, which means we don't have any dimensions in the top cord and the bottom cord. So that makes these calculations a lot simpler for us. But let's say we have a 32-foot span, and we're going to go a 10-12 slope. I'll usually a steeper slope for these. And let's go 9 feet from the wall on each side. So here's what I want to know. I want to know my wall height. I want to know my ceiling height. I want to know the overall height of the truss. And I still want to know J. Well, the first thing I can find is my ceiling relatively easily. How do I find my ceiling? Can anybody show me? Tell me. Yeah, 32 minus the 2 9s gives me 14 feet. So this is 14 feet across the ceiling of that. 14 feet across the floor of that, the attic room.
Which one are we on? 61?
Nope, this is just one I made up. So we've got 14 feet across there. Now again, this is all assuming no dimensions, no thickness to the top and bottom cord, so there's obviously some assumptions made here that aren't realistic. We're simplifying it for the sake of the math. Next, let's find the height of the wall, W here. We know that's W, and we know that this is 9, and we know it's a 10-12 slope. So 10 over 12 equals W over 9. Cross multiply and divide, you're going to get 7.5 feet. Correct? So 7 foot 6 inches. Yes? No? Next, we're dealing with this triangle here to find the height. This is 16 feet, half of our span, that's H, and we're still 10-12. So 10 over 12 equals H over 16. 10 times 16 divided by 12. What'd you get? 13.33. Very good. So this is 13 foot 4 inches. At this point, you should be recognized whenever you see the 1/3 or 0.3 repeating, it's 4 inches. Same with 0.6 repeating or 2/3, that's 8 inches. Quarter of a foot, 0.25 is 3, and so on. Some of those should be, you start to recognize those a little bit. So this is 13.333 or 13 foot 4 inches. Now for J, it's just going to be the square root of that answer squared, of the 13 1/3 squared, plus the 16 squared. 20.827. At this point, I'm going to assume you guys can convert that into feet, inches, and sixteenths. Okay? Now, the next thing, of course, you'd add a heel height to that and overhangs. I want to see if you guys can handle that. So I'm going to end the recording for the first hour right here, and that you guys work for the next 8 minutes or so to conclude the first hour. Then we'll come back and talk about some more stuff.